Okay, so here in this presentation, we briefly explain how we automated backend tests that validate business rules in a database. Very basically, we receive a file that is integrated in a certain directory in a company server. And after these files are integrated here at this table, some transactions are filtered to a table. These transactions are okay, and the transactions that are not okay are filtered into another table. From the OK transactions, this is integrated into another table that is a so-called enrichment table, and it's a mapping table. So there is a mapping that is done for each field of the file. Currently, we have 69 possible tests that correspond to each column of the enrichment table, 57 of which were successful tests, 3 failed, 1 was aborted, and 8 remain to do. So if we open the test set, we can see that 69 columns are listed. This is the name of every column in the mapping table or in the enrichment table. And for each test of the test set, for each column of the enrichment table, there is a query which returns 1 or 0, depending if the value x is expected or not, respectively, as you can see in yellow. For example, for the field has been cancelled, which is a flag, it should always be populated with the value 1. In case it is always populated with 1, the query returns 1, else it returns 0. That was the case of the field has been cancelled, but there is another flag that is so-called has execution price. And this field, similarly to the previous one, this field should be populated with 1. In case it's not populated with 1, the query returns 0. What was done in .NET Core 2.0 was to add these raw queries. We are not using an ORM. We added the raw queries to the code. So for each query, there is a function created in C#. And each of the above methods return true or false in case the queries return the expected result or not, respectively. On top of those functions, there is a second layer of code where syntax belongs to a framework called Xunit. When we run those tests, we are using this assert notation. So the framework expects that the result of the method would be true. If the method returns 1, then it's true. If the query returns 0, then the method returns false. So if it's true, Xunit passes the test. If it's not, then the test fails. And as you may see at the left, all 48 tests pass, which means that all the columns in the enrichment table return the expected value. So we created a repository, installed Git locally on our machines. And once Git is installed locally, we can use these commands to send, so to speak, to send the code to the created repository. This is important that the code is stored in a repository because now instead of accessing our local machines to run the program, to run the tests, then a whole team can access the server and run the tests themselves. In this server, where the tests are run, is a different server where the code is located, but it's a dedicated Jenkins server. And here we can find a pipeline where the first step is to clean the workspace over here. Then the pipeline loads the code from the Bitbucket repository, here in yellow. And there is a need to set this SSL verify flag to false. Otherwise, one runs into this problem, an SSL certificate problem. This pipeline does have a .NET command that automatically runs the tests. This command is .NET test, and it's proper syntax. Here we can see the whole pipeline in yellow. It's a tricky part. So this is the part in which a Jenkins plugin is used to show this. This is the graphical results of the tests. The Jenkins plugin graphically shows how many tests passed and how many tests failed. This is the structure of the XML file that is generated. It shows the name of the column and the result of the test. Pass versus fail. After one builds the pipeline, we can find this XML file at the workspace over here. Finally, the last step imports the XML to Jira, creating a test execution. And this is all. Thank you for watching.